Hi everyone, and welcome to the Making and Breaking Conjectures series. Today I'd like to pose a really interesting problem, which is the question of squarable numbers. First off, what is a squarable number? Well, here's a definition. Call a number squarable if you can take that number of squares of any size and cover a square with them, or construct a square with them. So some examples really help us to see what this means. For example, 9 is squarable because it's very easy to take 9 squares, in this case all the same size, and use them to build a square or cover a square. What about a trickier number like 13? Is that a squarable number? Could we take 13 squares and create a perfect square from them? Well, it turns out the answer is yes. The trick is the squares are allowed to be different sizes, so here's a way to take 13 squares in 2 sizes, as the case is, and create a square. Now, your job today, and just looking at this, the question arises in my mind, which numbers are squarable and which aren't? Is there some kind of pattern or way to check that'll help us determine what the squarable numbers are and which ones aren't? My advice to you, first of all, is just play around, and sometimes you can really find surprises just by playing around. For example, I just started sketching on graph paper, and I ended up with this picture, which shows that 12 is a squarable number. It's a complicated picture, but you can check that all of those are squares, all the sides and all the angles of each one are the same, and they build a square. There it is. 12 is a squarable number. So here is the challenge for today. First off, try to find all the squarable numbers from 1 to 30. My recommendation for you is don't get hung up on finding, just one of them. Don't say, I need to find 19 and I'm not going to stop until I do. Try playing first and you'll find that there's some that are easier and some that are trickier. And you can start to deal with the holdouts later. Second is you're starting to record your data and really keep track of which ones from 1 to 30 work. Start to make conjectures, and you can try to break each other's conjectures also, for how to tell if a number is squarable or not. You're also free to test those conjectures on numbers greater than 30, especially if you've already exhausted your list. And third, can you defend your conjectures? So can you argue to someone else that your idea, your pattern for finding squarable numbers is actually true? I'm going to end there. Good luck.